Hey everyone, how you doing today? Wazoo here, and this is the Match 3 game that we're going to be putting together in our video tutorial today. Yeah, it's a really slick looking game with ASCII tiles instead of the typical Match 3 gems. But we can go ahead and match and take a look at the different visual effects that we're creating here. Whenever a match is made, the tiles turn green and some yellow highlighting for a score shows up on top of them. And notice how the large score in the top left corner will balloon up whenever it's increased, like there. So yeah, I think this is going to be a super cool video, and I can't wait to dive into this and put everything together with you. This is going to be so much fun. All right, let's check it out. Hey everyone, how you doing today? Wazoo here, and in this video, we are going to be talking all about Match 3's ASCII text, Raylib, and the C programming language. Yeah, I think it's going to be a whole ton of fun today. I'm really looking forward to getting started. The Match 3 type of game is still one of the most popular genres, as titles like Candy Crush and other similar games are still enjoyed by millions of players worldwide, even in 2025. But for me, my Match 3 heaven was with the release of Bejeweled 2 from PopCap Games way back in 2004. Ooh, so long ago. Everything came together for this title, and with the type of polish that PopCap Games was known for back in the day, it quickly blew up on the game portals, selling millions of copies. Let's dig into this type of game and put one together in the C programming language using Raylib. Let's lock in and get started.
Boom shakalaka!
So as you can see in front of you, I've got Visual Studio open and a blank main.c source file all set up and ready to go. I've just created a normal console app, and I have Raylib installed on my system. So what we're first going to do is set up our main game loop and then slowly try to layer in everything we need for our Match 3 game. So we're going to be including raylib.h and a few other standard C libraries. So next we're going to define the size of the board. So this is how many tile spaces to the right and down that we will have in our grid. And so we're going to start with 8. But again, since it's an easy configurable value, you can play around with different sizes as you're going through putting this game together. And then we're going to create a similar variable to hold our tile size. And I just came up with 42. That seems to be kind of a nice, easily divisible number, and it looks sort of good. Again, feel free to resize to whatever you want. And tile types we're going to put together is 5. So basically we're going to have 5 different kinds of gems. Usually an odd number works best for some reason for these kind of games. So, and next we're going to create an array of chars. And we are going to use the hashtag, the @sign, the money sign, %sign, and the and symbol. Oh, and I misspelled. There we go. That should be tile, not title. Tile size and tile types. All right. And then we are going to create a small char 2D array to hold the board. So board size times board size. Okay, perfect so far. So first we're going to create a small function to randomly generate the tiles that we want to display. So we're going to create a function, a C function that'll return a char character. And all we're going to do is grab a random one from our tile chars array there. So use the random function modded with tile types. Easy peasy. Okay, then we're going to create a initialization function to just basically loop through our board here and fill it with random tiles. So void init board, and we're going to create 2 for loops. Y is less than board size. Y++, and same thing. X is less than board size. x plus plus, and then we're going to have board y x equals random tile. Sounds good to me. So next we're going to jump into our main function already. So it'll be a pretty standard main declaration. And we are going to come up with a screen width and screen height. So const int screen width. And I chose 800 by 450, and I'll show you why momentarily. Okay. And then we are going to call init window, screen width, screen height. Don't you just love IntelliSense? And let's call this project Raylib 2D ASCII Match3. Something nice and descriptive and long. We're going to set our target FPS to 60. And we're going to seed the random number generator using srand and feeding it time of null. So we're going to just call init board, since we've already set up that function. And then we are going to set up our main while loop. So while not window should close. And this is where all of our game logic will go. But for now, we are just going to be drawing the board. Okay. So we have a begin drawing. We're going to clear our background. Let's use black for now. And we're going to finish it off with an end drawing. And then after the while loop, we're going to use close window to close down our game window. And I guess that's it. We don't have to, oh, we do have to return something. Let's return 0. Everything looked okay. Okay, so in between, before we test this for the first time, let's quickly draw our tiles. So in between the begin drawing and clear background, let's do our for loop. The same one we used basically when we set up the board. So y is less than board size, y plus plus, and for int x equals 0, x is less than board size, x plus plus. So we're going to create a rectangle of the tile. So rectangle rect equals, and we're going to do, for the x position, we're going to do x times tile size. And for the y coordinate, it'll be y times tile size. And then the width and the height will be tile size. Okay, an easy piece to create there. And then we are going to draw rectangle lines x using the rectangle we just created, a line thickness of 1. These are for the outer borders of the board, you'll see momentarily. And we'll use dark gray. Okay, and then we're going to draw the tile itself. So vector 2 position equals x times tile size with an offset, and y times tile size. And you'll see this offset why we're doing this in a minute here. Oh, that IntelliSense. Okay, so we've got drawing the outer rectangles of our grid, and let's draw the actual tile itself. So we're going to use a function called draw text x, and we're going to get the font default. We need to pass in a string to this function, but we've got the tile is a type char. So we need to convert that into a string. So to do that, we use text format, and we use %c, and then board y x. Okay, next we have to create a vector 2 for the position of our tile. So it'll be rect.x with a little offset and a rect.y with an offset. and then it'll be font size of 20. Wait for now. Okay, so that should be all we need to get our basic grid going. Okay, let's build it for the first time. And you can see that we've got a window. And you can see our game board is coming up with our different ASCII characters, different tiles, which is really cool. All right. So notice how it is in the top left window, top left section of the window. So I would like to center that within the window itself. So let's go ahead and do this right now. And at the top here, we're going to add a vector 2 called grid origin. And this will just be a way to calculate the offset. So down here in our drawing, what we need to do is in this section here where we're calculating, where we've got our rectangle being defined, we need to go ahead and offset it by our grid origin.x plus x times the tile size, and then our grid origin.y component. Okay, so back up in our init board function. Okay, we first take the width of the grid, we calculate that out. So grid width equals the board size times the tile size. So we calculate the pixel width, and then we calculate the height, same way, with board size times tile size, since the x and y, the width and the height are basically the same. And then we calculate grid origin equals, it's a vector 2. And what we want to do is we want to get the screen width and subtract it by the grid width and divide this by 2. And for the y, we get the screen height. We subtract the grid height, measurement of the grid height, and divide that by 2. And if all goes well, we should be able to run this. So there we have it. So we have our centered grid on our black background, and so far, so good. All right. So now let's add an image. So I've gone ahead and I come across this space background image, and it is, I'll blow up the size here, but it's 2560 by 1440. Using any image tool, if we try to resize this image to 800 width, we get a height of 450, which keeps this aspect ratio in place. And that's how I came up with the 800 by 450 for our window size. So I've dropped this image into the assets folder that's in the project. Again, when you pull down this project, you'll have all the assets in the assets folder, and you can easily find your own image to drop in as your background. You don't need to use mine, of course. And so let's declare our background. So texture 2D, background. Okay, so then before we call init board, okay, we can use a function called load texture. So background equals load texture, and then I've called it background.jpg. Very descriptive, but nice and easy to find. So then we initialize our board, and then when we're drawing, okay, let's draw it to black. And then what we want to do is, sometimes you might have an image, which in our case is a lot larger than the window of your game. And so we can use some easy Raylib functions to just keep that aspect ratio, but resize the image. So we use a function called draw texture pro. Okay, and the texture 2D that we want to reference is our background texture. And then we want to calculate a rectangle of 0, 0, and our width and height of our image, or texture, sorry. Then we need to calculate the dimensions of the window to drop this in. So again, we're going to be using another rectangle. And this time we just need to use get screen width, and get screen height. And then we're calculating a offset here, but it's just going to be 0, 0. And then the color that we want to use is white. And then, of course, when we're cleaning up here before close window, we need to unload our texture to just clean up our resources properly. Okay, so if we hit our play button, we should have a background behind us. And we do. All right. This is pretty cool. So we've got our grid showing up. We've got a pretty cool, the tiles have a neat effect. I'll just go back for a second and talk about the character offsets. So remember how when we're drawing our tile, we're just adding this +12 and +8. And this is because the font size that we are drawing our tiles is smaller than the space of the entire tile. Remember, the tile size is 42. I believe we've declared it. So we're drawing with a much smaller font size in order to give the visual impression of like a real tile, that we're not taking up the entire thing. So if we remove, I'll show you what it looks like if we remove this +12 and +8 offsets. So you'll see that they're just appearing in the top left of the tile. So giving it those offsets helps it to give it a centered look within the tile itself. So let's just restore that. Okay, 12 and 8. All right. So we're coming along pretty good. And let's just display a score in the top left corner. So I'm going to create a score variable. So just int score. And we'll just keep it at 0. You know what? I'll leave it at 200 for now, just so it gives us some kind of visual thing. So just before the end drawing here, okay, and again, we want a text format. And we'll just use score. And then it's an int, so we use %d, and then a score, and then we're giving it a 2020, and then let's font size of 24, and we'll use yellow. And this is a basic way to draw text within Raylib. Let's just make sure this works. Okay, cool. So we've got a score of 200, easy peasy. So now let's use a actual TTF font. So in the assets folder, I've got a TTF font that we can use. Okay, here it is. Okay, so this is the 04 B03 TTF font. It was one that I used to use all the time back in the Flash days. It was I think the default font for the Flashpunk game engine if you use to program Flash games. I've kind of pulled that font out and I use it everywhere just about all the time by default. I think it kind of looks cool, looks pixely. You can also use the Press Start 2P font, which is another popular retro arcadey looking TTF font that's available on Google Fonts, I believe, for free. Okay, so in the assets folder, we've got that font file. So let's go back again to the top, and after our background, let's use, we'll declare a font, and that'll be our score font. Okay, and then after we load our background, let's go ahead and load our score font. So score font equals load font EX. And we're using the assets 04 B03.ttf. And I've created a variable here called score font size, which I didn't yet declare. So let's go back and do that. And then the other two parameters are null and 0. So let's declare score font size, and we'll declare it to be 32. Okay, so we load up the score font with the given score font size. And now when we go down to draw the score, okay, here we are. So we comment that out because we're not going to use it anymore. So we'll use a draw text EX, and we'll first declare score font as the first parameter, And then our text will be the text format score %d score. Okay, and then we will use a vector2 of 20 position 2020 to keep it in the top left corner. And then what we want to do is we want to use the score font size and then 1.0f, and then we want it to be yellow in color. Okay, and then again, when we unload the texture, let's also unload the font. Just to make sure we remember to do that, let's clean this up. Okay, and let's see if this works. Okay, so we've got our font coming up with our special, we've got our score label coming out in our special font file that we've loaded, and it is rendering in the top left corner at 2020. So we are slowly making some progress here. All right. So now let's track mouse clicks and see if we can highlight the tile that we click on. So just before we go into our main game loop, let's create a variable to hold our mouse, current mouse coordinates. So a vector2 of mouse, and then right up here, as we get into the game loop, let's just use mouse equals get mouse position. And then if we click the left mouse button, so if is mouse button pressed, mouse left button. Okay, then what we want to do is get the X and Y coordinates. So since our grid is offset from between the width and the height of the window, we also need to offset the mouse calculation. So int X is our mouse X position minus grid origin.x divided by tile size. This just gives us the tile that we've clicked upon, is what I'm trying to say. So the mouse Y minus grid origin.y divided by tile size. Okay. So now if we've clicked within the board, so if X is bigger than or equal to 0 and X is less than board size and Y is bigger than or equal to 0 and Y is less than board size. So we need to keep track of our selected tile. So back up top, let's create another variable here to hold that. We'll call this one, it's a vector2d, and we'll call it selected tile. And we'll initialize it to -1, -1. Okay, and then back down in our function here. So we've clicked somewhere on the grid, and we've calculated that we are within the coordinates of the grid. We are within the boundaries of the grid, sorry, not the coordinates. We are within the boundaries on the grid. So let's grab our selected tile equals. Okay, and then down here in the drawing code, after we've drawn the board, and before we draw the score, let's draw the selected tile. Draw selected tile. So if selected tile dot x is bigger than or equal to 0, so if we have something there, then we draw the rectangle lines EX. So our first parameter there is a rectangle, and we're going to use the grid origin.x plus selected tile.x times tile size, and then the grid origin.y plus selected tile.y times tile size. Okay, and then a width and height of tile size. Within yellow, we're going to be drawing the border of that tile as yellow. So let's go ahead and try this out. Okay, do I need to cast that to vector 2? Okay. So let's go ahead and do that. And let's run that and see what we get. Okay, so if we click on the top left. Ooh, and then if we click outside, we don't update it at all. Ooh, that's nice. I like that. Okay, things are coming along really cool. All right. Okay, so now the first thing we're going to do is let's create a function to check if we have matches in our board. This is kind of the heart and soul of any Match3 game. Okay, so after random tile, let's create a new function called find matches. So bool find matches. And it will just return true if there's any matches, and false if there's none. So bool found equals false. That'll be our default. And we are going to create another board to hold any matches. Okay, so we're going to call it matched. And again, it'll be the same. It'll be the board size, a two-dimensional array of board size and board size. So basically what we're going to do here is we're going to loop through our tiles and see if there's a match of 3 tiles together. And if there are, then we will highlight them green. Nothing else will happen. We can't click on them to do anything yet, but I think that's the gist of the aim of this section of what we're trying to do. Okay. So we are going to reset the board here, our matches board, or matched board, sorry. So for int x equals 0, x is less than board size, x plus plus, and our matched yx equals false. So we're going to reset everything to false. And then what we're going to do is we have to go through the vertical, we have to go through the board in columns and the board in rows and look for matches there. So hopefully this will become clear as we're typing out all the code here. Okay, and then another inner for loop. So for int equals 0 and x is less than board size minus 2 and x plus plus. Okay, so we grab the current character. So char t equals board yx. So if t equals, so we look around it, we're using the tile and we look around to the neighboring tiles. So first we're looking to the right, to the tile to the right, and t equals board y, and then to the further right. So then we label all 3 of those tiles as matched. So matched yx equals matched y x plus 1 equals matched y x plus 2 equals true. All right. And this is where we've basically got a match. So here we update the score. You know what? Let's just do that quickly now. So score plus equals 10. So we've got eventually we'll put sound effects there. And then now all we need to do is the same thing for our vertical. So notice this -2, we're only going to the -2 across. And this is because since we are checking all the way from the left moving to the right, and we don't want to go out of bounds of the grid if we take out this -2. So we need to do the same thing vertically. So for int, let's do it this way. So x less than board size, x plus plus, and then for int y equals 0, y is less than board size minus 2, y plus plus. And then same thing, we grab the tile, so char equals board y x, and then if t equals board y plus 1 x and t equals board y plus 2 x. Okay, and then we mark them all as matched. So matched y x equals matched y plus 1 x equals matched y plus 2 x equals true. And then we increase our score. So score plus equals 10. And the one thing we also need to do is we need to set found to be true. So we found a match. So same thing up here. Found equals true. And that should be all we need to do to find our matches. So let's return found. Okay, now the idea here is that I just want to draw the tiles that are already matched. Okay, so we're populating our matched board. Find matches. Okay, so let's just call find matches. And this will we'll only be able to see any matches if we've generated 3 pieces together. Okay. So to highlight the ones in green, all we have to do is go down to our draw text X function here, where we're drawing the actual tile. And then for this color calculation, instead of white, what we can do here is let's make this a small function instead of white. So let's create a ternary function here. So if matched yx is green, if matched yx is true, then we want to draw green. Otherwise, let's draw white. So let's see if this works. And if we get lucky. Oh, we got lucky. Okay, so notice how we've got some tiles that are 3 together and they are matched of the same type, and our match algorithm looks like it's working. Let's just double check visually here. And I know it's not really a solid proof, but so far we don't have a lineup of 3 of the same tiles anywhere else that is not green. So we see our tiles are green, we can highlight them, and our score just keeps going up because, of course, we keep calling find matches every frame. Okay, so now what we can do is let's go ahead and remove our match tiles. Okay, so to do that, we're going to create a function called resolve matches. And let's just go back up to our, okay, so this is found matches, I'm assuming. Yep, find matches. And let's create a function here called resolve matches. The whole goal is to remove the matched pieces from our game board and then collapse all of the tiles on top of them so that they move downwards. And then any empty spaces that are at the top of the board, we replace with new random tiles. Okay, so for int x equals 0, x is less than board size, x plus plus, and then we're going to do int board size minus 1. And then we're going to do another inner loop. So for int y equals board size minus 1, y is bigger than equal to 0, and y minus minus. So if not matched yx, then board yx equals board yx. minus minus, and then we want to fill, once this inner for loop is done, we want to fill empty spots with new random tiles. So while right y is bigger than or equal to 0, board right y x equals random tile, and then right y minus minus. So if the find matches returns true, then we want to resolve them. So if find matches, then we want to resolve matches. Okay, so this should work. Okay, so that happened so fast that we didn't see anything. All right, so we had some matches initially, which I did briefly see green for a quick second. Let's try that again. Bloop. So we have green tiles that matched, and then they were collapsed and removed from the board, and new ones popped in at the top. But now let's add in some animation, because that, of course, is just too ridiculously quick. Okay, so what we want to do here is at the top, we want to create another array, and we will call this fall offset. And this will just help us to track the animating tiles throughout the board. Okay, and then here we'll need another variable called fall speed. And we'll give it a value of 8. Maybe we can declare this as, you know what, let's just do that. No, let's leave it alone, 8.0f. Okay, so then back down in our resolve matches, what we're going to do here is most of this stays the same, but we're going to introduce a delay. If not matched, yx, if y does not equal to right y, then what we're going to do is board right y, x equals board y x. And then we're going to add the fall offset equals right y minus y times tile size, and board y x equals empty space, so empty char. And then we're going to take this out, subtract 1 from right y, and then down here in this while loop, while right y is bigger than or equal to 0, we are grabbing the random tile, and then we're going to use that fall offset again of right y x equals right y plus 1 times tile size. Okay, now let's look to animate this. So in our updating logic, what we're going to do is rework this section here, because we don't want to keep, we have to introduce a delay to the find matches to account for the tiles being animated. Otherwise, it's going to look really wonky, and we'll be updating this section quite a bit here. So we're going to introduce a double for loop again. So y is less than board size. And then for int x equals 0, x less than board size, x plus plus. And then if fall offset y x is bigger than 0, fall offset y x less than equals fall speed, which we declared above. And then if fall offset y x is less than 0, fall offset y x equals 0. So just fall to the bottom. Okay, and then let's put that underneath our find matches. Okay, so down in our drawing tiles, okay, so we've got our whole, draw the grid, draw the tile. What we're going to do here is surround our tile with a if board y x is not equal to the empty space. Then we draw our tile. And what we need to do also is adjust our y value here with the fall offset. And let's see if this works. Okay, that actually looked pretty good. It went by pretty fast because we are not doing anything there. Okay. But that actually worked. All right. I am super happy with that. Okay, now what we need to do is let's look at swapping those tiles. So where we click on a tile and we swap to the one next to it. So back up near the top, let's create a function called swap tiles. And all this is going to do is swap tiles. Swap tiles, and we're going to be passing in 4 variables here, x2, int y2. And really it's temp. We'll grab the y1, x1, and then we'll swap everything around. So board y1, x1 equals board y2, x2. And then board y2, x2 equals temp. And then we need another small helper function here for testing if the two tiles are adjacent to each other. So bool, we want to return a bool, are tiles adjacent. And we give it 2 vectors. So we want to return the abs a.x minus int b.x plus the absolute value of int a.y minus passing to an int b.y equals 1. Okay, so down in the where we have the mouse grabbing. Okay, so we've got our section here on we've got our selected tile. Okay, so what we're going to do is we're going to update this logic here. So current tile equals vector 2 x y. So if selected tile dot x is less than 0, then selected tile equals current tile. Okay, so next, else. So if our tiles adjacent, selected tile and current tile, then we want to swap the 2 tiles. So swap tiles, selected dot x, selected dot y, selected tile dot x, selected tile dot y, and current tile dot x, and current tile dot y. Then we call our find matches. So if find matches, then we want to resolve those matches. Otherwise, we need to swap them back because they weren't a match. And so we don't want to allow tiles to move that don't result in a match. That's typically match3 rules. So swap the tiles back. So selected tile.x, selected tile.y, and current tile.x, current tile.y. And then if the two tiles aren't adjacent, then we reset selected tile to be -1, -1. Okay, so let's see how that comes together. So we can select a tile, and here we go. We can select a tile and try and match it. Okay. So we've got another bug here somewhere, but it does run the algorithm correctly. Okay, let's try and swap these two. Okay, there's that. Okay, so that didn't work. That didn't work either, which is good. That wasn't allowed. I didn't say that didn't work. That wasn't allowed. And that wasn't allowed. And so let's try swapping these two. Nope, that wasn't allowed either. And that wasn't allowed either. Okay, so sometimes, for the most part, our logic seems to work and hold up. Okay, so we've got a other problem, which will creep in, is that we're able to click while tiles are still animating. So we need to create a way of preventing input while there's animation going on. And so the cleanest way I could come up with was creating a state system to handle when we're animating tiles and when we're ready for input. So at the top, after our fall speed there, let's create a enum. So we have an idle state and a state animating. And actually, I think all we need is just these two. Okay, so we've got two states. We're idle or animating, and we are going to call this one game state. We could call it tile state. Maybe tile state would be a better. Actually, that's a much better way, I think. Okay, so let's call it tile state. Because when I think of a game state, I'm thinking more of things like what screen are we on? Are we on our main menu screen? Is our game over? Things like that. I wouldn't associate it with animations and input necessarily. So let's call it tile state. Let's declare a tile, oops, help if I could spell state correctly. Let's declare a tile state variable. So just double checking we haven't done that up here. Nope, okay. So now what we can do is let's go down to our init board. Okay, so we're initializing the board, we're offsetting and calculating everything. Okay, so what we want to do first is run all of our matches against the board right away so that any matches are already cleared before we even allow the player to start working with the board. So let's if find matches. Let's go ahead and call resolve matches. And then otherwise, if there's no matches, then we set the tile state to be state idle. So we're ready for input. And then in the resolve matches function at the bottom here before you return, let's go ahead and set the tile state to be state animating. Okay, so then down here in the main function, so if our tile state is equal to state idle and we've pressed the left mouse button. So if we're able to like if we're not in the process of animating anything. Okay, so then let's go down to our animation, and we'll tuck this into an animation state. So if tile state equals state animating, and then everything here, all this fall offset, let's tuck that within the, so if fall offset is less than 0, we set that to 0, but otherwise, if our fall offset is not less than 0, then our still animating flag is true. And then, okay, right at the end of this block here, if not still animating, then tile state equals state idle. Idle. Okay, I hope that's okay. I hope that's all we need. Let's see how this works. Okay, so it somewhat looks okay. So that's is sort of looking okay. Okay, and I think we need to create, I think what's missing is that we need to create another way to run the match tiles after tiles are falling to see if there's other matches in place. I think that's where some of the logic is getting missed here. Okay. So we've got a fall speed. Okay, and then we want another variable here called match delay timer and a match delay duration. And then in these list of states, we need to add one called state match delay. Okay, let's go back down to our big loop area here. So state animating. Okay, so if not is still animating, what we want to do is instead of setting it to idle, we want to set the tile state to be state match delay, and then set the match delay timer to be our match delay duration. Okay, and then account for that. So if tile state equals state match delay, then we subtract the get frame time. And then if that match delay timer is less than or equal to 0, so then we if find matches, basically rerun everything again, resolve match. Is it called resolve matches? I still resolve matches, else tile state equals state idle. Okay, so that looks more correct. So if we found a match and we're animating, then continue to animate, and then once we finish animating, move the tile state to another state where we then update another timer. And then once that timer completes, run the find matches again and resolve them. Okay, so we've got so if find matches, okay, we missed that bracket. So let's try this again. Okay, so now we got our pieces properly clearing, and we got our matches running. The green is now going away. Okay, and this is looking so sweet. All right. All right, so we got scores, and it's constantly running. Okay. So now what I wanted to try, oh, wow, that was cool. All right.
Super combo!
It's like a 5-hit combo. Anyway, so one effect I wanted to add here when I drew this grid, if you'll notice here behind the grid, we see our planet, basically the background, and it's very difficult to see some of these tiles in this section here because they're covered by the lightness of the planet. So what we can do is just basically draw a rectangle right behind that grid and make it easier for everything to pop out. Okay, so down when we draw the background rectangle here, okay, so we draw the background. And then what we want to do is just before the grid, we draw a grid background. So we draw just a straight rectangle behind there. So draw a rectangle. And then we have our grid origin.x, grid origin.y. And we've got our grid width, so board size times tile size, and then our height of board size times tile size. And then we can use what's called a fade. So the color, we can actually use an alpha value. So we can fade. There's a function called fade. We want to use dark gray as our color, not dark Gary, dark gray. And let's do a 60%. Basically, we'll fade it. We'll give it a translucent feel, but still be dark enough that maybe we can see things. Okay, so look at that. So we've got a light translucent alpha black square behind our game grid, and so it makes it slightly easier to see our actual board. So let's change that to 1, and I'll show you what this is doing for us. So 1.0f. And it should just be a straight black board. Yeah. So we've got this here. So you can keep this if you want, of course. It's up to you. It's your project, whatever you want to play with. I just preferred having it a little bit of a translucent background there. Okay. So now let's go ahead and play a sound. So I've got sound effects, well, one sound effect in the assets folder. So let's go ahead and load that. So first we're going to declare that at the top. And as well as some music. I've got some music. Let's just do both in one. So we've got a music object. We'll just call this background music, and a sound object. I just called it match sound. Okay, and then down in our main, there we go. Okay, where we're loading our background and our font, let's load our background music. So background music equals load music stream, and the file is called bgm.mp3. And then our sound, match sound, is load sound assets match mp3. And right away we're going to play the background music stream. So play music stream background music. And then within our main loop, we need to call update music stream background music, just to keep the music going. Okay, and then let's, right at the end here, before we do anything else, let's stop the music stream. Background music. And let's unload the music stream. Background music. And let's unload the sound. Unload sound. And that was called match sound. And before we call close window, we need to actually close audio device, which means we've got to call init audio device. So we should do this before we load any of the assets, just to give the system time to, just to give Raylib time to initialize our audio stuff. Okay, so we've got our background music, and then we've got our match sound effect. So when we increase the score, all we have to do is play our sound. Play sound, match sound. And then again, play sound, match sound. Okay, let's see how this works. Okay, so we've got our background music looping. time sounding for matches. Okay, that was cool. All right, so the last thing I wanted to try and tackle was a little effect, if you've noticed in our game demo, of the score text popping out at us every time there is a... Oh, okay, so one thing I wanted to do is when there's a match right here of our tiles, I also wanted to display the score in a small animated value above the matched tiles. So let's go ahead and do that now. Okay, so since we're right here, we'll stay right here. So we update the score. Okay. We update the score. We set our found to true. We play the sound. And then what we want to do is we want to call add score pop-up. And we'll give it the X and Y tile 10 and our grid origin. Okay. And then we want to say our score. Okay, no, let's, okay, so we've got our score, add score pop-up. And we want to do the same thing down here. So after play sound, we then call add score pop-up. And then now what we want to do is let's create a small array of score pop-ups. Okay, so after our tile state, let's create a struct, another struct, and we've got a position. We've got an amount, then we've got a lifetime and an alpha value for our color, and if we are active or not. And so this is a, whoops, this is a score pop-up. And then we're going to create an array of them. So score pop-up, score pop-ups, and then max score pop-ups. Okay, we'll initialize that. And then of course we need a max score pop-ups, and I just came up with 32. Play with that. With whatever you want. Okay. So now let's create a add score pop-up function. So just before our find matches, maybe we can stick this here. So void add score pop-up. So we want the X and Y, our position basically, the amount, and the origin of our board. And that's just to help with the offsets for offset. For the board offset of where to place this scored effect. Okay, so we have a loop here. We're just going to basically find an empty entry in that score pop-ups array. And so if not score pop-ups active, so if we're not active, then we can use this entry in the array. So score pop-ups I dot position equals vector 2, and let's create it with the grid origin dot x plus x times tile size plus tile size divided by 2. That's a lot of math. Grid origin dot y plus y times tile size plus tile size divided by 2. Okay, and then the score pop-ups I dot amount is equal to amount, and score pop-ups, pop-ups I dot lifetime equals 1.0f. So that's how long we're going to animate it for. And score pop-ups I dot alpha is equal to 1.0. And finally, that this slot is active. So active equals true. And let's break. Okay. So now what we want to do in the updating section is update that array of score pop-ups. So let's get back down here to where we are doing our, just before our drawing, and let's update our score pop-ups array. Okay, so for int I equals 0, I less than max score pop-ups I++. So if score pop-ups active, then what we want to do is subtract the current frame time, and then subtract the Y position to basically make it float upwards. Position.y minus equals 30 times get frame time. And then we want to adjust the alpha value to slowly fade it out. Alpha equals score pop-ups I dot lifetime. Okay, and then of course, just some basic logic. So if score pop-ups I dot lifetime is less than equal to 0, then score pop-ups I active equals false. Beautiful. Okay. So now down in our tiles section, so just after we draw our selected tile, and we've now drawn the score. So just before end drawing, let's go ahead and draw our score pop-ups. Pop-ups and I++. And then so if the current score pop-up is active, okay, so we're going to calculate the color. So color equals fade, yellow, score, pop-ups I dot alpha. And then we use draw text, text format, and let's give it a little plus sign, %D. And then we'll use the score pop-ups I dot amount. So draw text. Okay, let's separate this out to make it easier to see. Okay. So we've got text formatting of the amounts. You already got lost. And then we've got the score pop-ups position, and then the font size, which is 20, and then the color. So let's call it color C. Okay, so now let's see. Theoretically, this should work. And let's see what happens. Okay, so we've got the score coming up. See how the text is fading away? 10, 10, 10, and it fades away. Okay, so we've got that amount. So the last thing I wanted to tackle is having an animated score. And so this is when the player, when the score is getting updated and the score text just kind of pops out at you. Okay, so let's go back up to the top in our favorite section of all these variables. So we've got a score font and our score. So let's reset this to 0. And then let's add in some more variables here to track that. So let's give ourselves a score scale. So basically we want like a large scaled font and then have it shrink back down to 1. Score, scale, velocity, and then an animating variable. So, and is the score currently animating? Okay, so then down in our find matches, okay, so we are updating the score, we're playing the sound, and then we add that little score pop-up. And then so what we want to do is our score animating is set to true. And our score scale is, let's give it 2, a 2.0 scaled font, and then a score scale Velocity, we could call it timer, equals minus 2.5 f. So basically over time, it'll shrink back down to the regular size. Okay, and then let's add it as well here. And then finally, in our updating section, before we draw anything, so after the match pop-ups section that we just added here, let's update the score values, like basically the score sizing, score animation. So if score animating score scale plus equals score scale velocity times get frame time, if score scale is less than or equal to 1.0 f, score scale equals 1.0 f, and score animating equals false. Okay, so that should be all we need to do. And then finally, when we draw the score, where are we here? Okay, so here's the text. Tiles, this looks like the score. Okay, so we have our position, and then we have our score font size times our score scale. I think that's really all we need to update. Okay, that looks right. Let's go ahead and run this and keep an eye on the score. Oh, look at that. Oh, that is so cool. Makes me want to snap my fingers. Anyway, let's go ahead and let's do one more. Anyway, that was it. That was the Match3 project that we've put together. We went through a lot of little bits to put together the effects for this game, the way all the pieces look and animate, and little tiny details like the scores updating, the little tiny animations there. So I think there's a lot of value in what we put together today. I hope you had a really good time on this video. I had a lot of fun on putting this project together, as you can see, and I am so looking forward to working on the next one. I hope you have a fantastic day wherever you are in the world. Don't forget to like and subscribe to the channel, and leave a comment down below as to any kind of tinkering you did with your game. I'd love to kind of hear and creative stuff that people are putting together using what we've learned in these videos. Have a great day, everyone. Peace.
Hyper Combo!